Hey there, my name is Gary Sims and this is Gary Explains. Today I want to take a look at regular expressions. Now, a regular expression is a way of defining a pattern for searching through some text or searching through a string to find particular matches. So if you want to find out more about regular expressions, please let me explain. Now, regular expressions are one of those things that pop up all the time in different areas of computing. For example, if you're doing any kind of system administration on Linux or on something like FreeBSD, then you're going to come across regular expressions when you use a tool like grep. And we'll talk about grep in a moment. But also, if you're doing any kind of programming in any of the major programming languages, whether you're an amateur or a professional, you're going to come across regular expressions when it comes to string matching inside of the computer program. So basically, a regular expression allows you to define a pattern so that you can match certain sequences of characters. And it's one of those things that we could study all the theory about the language, but actually I found that the best way is to see it in practice, and then you kind of say, now I understand how it works. So to do that, we're going to go over to a Raspberry Pi and we're going to use the grep command, which is a very, very basic command that you find on Linux and on FreeBSD. And the R and the E inside of grep, G-R-E-P, the R and the E there is regular expression. Okay, so it's a tool that's designed for finding strings based on a regular expression. Okay, let's go over to the Raspberry Pi. Okay, so here I am on my Raspberry Pi. Now I have a file which contains the full works of Conan Doyle for the Sherlock Holmes series. So there it is there. It's a long, big text file. If we do a word count on it, we can see that it is pretty big. Let's see how that comes up. Look at that, 107,000 lines, over 500,000 words. That gives us something really good to search through. And as I mentioned, we're going to be using grep, which will search for a string. So if you just do grep Watson in Sherlock.txt, then of course you get all the occurrences of the word Watson. And that is a very simple way of just searching through a file. Now, what's interesting about regular expressions is that they are completely case sensitive. So if I search now for Watson with a lowercase w, then it doesn't find any. Now, there is a way of actually doing a grep which is case insensitive, but I don't want to talk about grep's flags and grep's different options. I want to talk just about what you can do inside regular expressions. So if we take another example, if we look for the word, let's say, sum, okay, and we search for that, there we find all the words sum, but they all begin there with a capital S. And if we search with a lowercase s, we'll get different words highlighted there, the word sum with a lowercase s. So what you can actually do, and here we are now going to look at our first part of regular expression, we can say square bracket, which means you're going to start a list, and then we put in it S, big S, and little s. And then we have OME. So what we're basically saying is I would like to match big S or a little s followed by OME. So now if we search for that, we actually find that we get examples where we have a capital S. There's an example with a capital and an example with a lowercase. So there is your very first kind of regular expression saying you'd like to match something from a list followed by some other letters. Now, of course, you can do it the other way around. You can have that in the middle or at the beginning. You can form this expression this way any way you want. So, for example, we can look for the word realize. Okay, and here it is using the spelling with a Z or a Z. Now, what's interesting is this book also has, for whatever reasons, it has the alternative spelling as well. This is the difference in British English and American English with an S in it. Okay, so we've got both of them in there. So how would we search for that inside of a grep regular expression? Now, first of all, I'm going to put this now in quotes. That just makes sure that what we're typing in here is recognized to be a parameter for grep and not something that the command line, the bash shell, wants to try to find. So now here, we can also put a Z in there. It doesn't have to be in that order. You can put it that way around as well. So we're saying match the word realize with either a Z or an E. So here you can see the list of what we're trying to find is in the middle of the word. And if we do that, we will see that we get both of them matched there. Here at the bottom you can see one with an S, and then here you can see one with a Z. Now, there are other things you can do to alter the way you search. For example, if we were just to look for the word wind, Okay, that would find wind, window, whirlwind. These are all things that words that I know are inside of this text file. So you can actually say, by using \less than, I want only the word wind when it is the beginning of a word. So \less than means beginning of a word. So that will exclude, for example, whirlwind, but it will find wind and window. So here we find wind, and here we find window, for example. Now we can actually say, well, what happens if I also want just the word wind? You can actually say the beginning and the end of a word. So if you do that now, you can see it's only matched the word wind through all of these examples. Now you can also make that a bit easier by saying \b, and that means on any word boundary. You don't have to specify the beginning or the end. Just say at a word boundary. It doesn't matter where you are, and that we don't have to remember the less than, greater than. It just means at the beginning or the end of a word, and there we can see it's matched the same things. Now another thing you can do with grep is you can say I want something only at the beginning of a line that matches at the beginning of the line. So we can just search for the word the with a capital T at the beginning of a line, and there you can see it just matches the all the way down there, only at the beginning of a line. Not here, for example, this one here in the middle of the word. It doesn't match that. It's matched the one here at the beginning of the line. Also, we saw the word there. So if we put this to be on a word boundary now, then we're only going to get the. We're not going to get there. You notice there that wasn't matched in there. Okay, so another thing you can do, again, at the beginning of a word, is we can say, well, let's find all the lines that begin with either A, B, C, or D, for example. So that will now list out all of the words that begin with, all the lines that begin with A, B, C, or D, because it's only at the beginning of a line. Here we are. We can see them all highlighted here. Okay, now you can also, if you wanted to go D, E, F, G, H, I, J, then that might be quite complicated. So you can actually put a list. So we can do A through to G, and that will just create that actually, it will automatically create B, C, D, all the way through to the list that you create. So that's a shortcut of making a range of things to match against. And here it's matching A through to G now, exactly the same way as it did with A, B, C, D a moment ago. Now, another thing we can do is if we could search, for example, for all 4-digit numbers inside the text. Now, to do that, we could have a list and we could say, 0, 1, 2, and start building up an expression that way. But there's actually a predefined thing, which is square bracket, colon, digit, colon, square bracket. And that says now I want a list of all of the digits. And now what you can say is / curly bracket for / curly bracket, and that says 4 instances. So not 3, not 5, just 4 instances of a digit, and that will help us find all the 4 digits in there. So there we go, all those years listed out there from when this was written and all the dates relative to that period. So that's a clever way there. Now, there are different flavors of regular expressions. So there are normal regular expressions, there are extended regular expressions, and there are Perl regular expressions. So there is another program called egrep, okay, which uses extended, and one of the main differences is a few of the characters don't need to have / behind them. So in egrep you can just do it like that, which you must admit does look a bit nicer, and that will find exactly the same thing. If we ran that program just on grep, it won't find anything because grep doesn't understand the curly bracket. It has to have the / behind it. So when you're using this in a programming language, for example, inside Perl or inside of a library that you get for C, C++, C#, whatever you are using, Python, you've got to work out, is it regular expressions or extended regular expressions or Perl-like regular expressions, and that will determine whether you need to use some of these / or not. Okay. Now, if we wanted to look for, let's say, the word flood, inside here, that's pretty easy. It can find it, and you can also look for the word, for example, fluid. So we can just search like that. Now you can actually search for both fluid and flood by saying ... here. So I want a word that begins with an F, followed by an L, followed by any character, followed by any character, and then followed by a D. So it's almost like solving a crossword. And it says any character can go in there, but it must be that, it must be a 5-letter word. That's what this actually says. It has to be a character, any character, followed by any character. And now if you do this, we can see it finds fluid and flood. Now you can do a very similar thing, but with optional characters. So here we're going to say, for example, if you have the word died, for example, it can find that inside of the thing. But also, of course, we have the word did. That's obviously found a lot as well. So how do you search for both of those? Well, what you actually do is you say, you include the letter that you want, E, for example, and then by putting \question mark, what you're saying is the E is optional. So it will match did and it will match died, because the E can be matched 0 or 1 times, but not more than 1 time. And now if we search for that, you'll see that actually it finds died and it found did, because the E was an optional search and it found both of those. So that's really quite clever. And here again, we have an example of where we could use egret for extended regular expressions, and we can get rid of the \. So it becomes DIE ? Makes the E optional D, and you can see that works. But if you try to run that through grep, it won't work because it doesn't understand the question mark without the \ behind it. Okay, I've got 2 more quick examples to show you, and then we will summarize what we have learned. If we want to look for some really long words inside this text, so we could start here by listing out A, B, C, D, E, F. Now there is actually a shortcut, which like before with digits is actually alpha. So that means all alphanumerics. Okay, and then what we want to say is like before, I want it to be, let's say, all 16 character words, but we'll learn something more here. You can actually say (17), so it says between 16 and 17. So let's have a look now for that, and look at the words we're finding here: enthusiastically and indistinguishable and misunderstanding. Those are all 16 or 17 long words. So that's a good way again of doing kind of matching for different types of things. Again, if you were doing crosswords or something like that, could be quite interesting. Okay, one more example. I can of course search for the month of June inside this file. I can of course search for the month of July inside of this file, and it finds both of them. So how do you search for both? Well, you can actually say search for June and then bar, meaning or July. And then that will search for both of those, June and July. And as you can see here, it finds July and it finds June. Now, there's obviously a lot of stuff to learn for regular expressions. You can really build up some very complicated and quite complex regular expressions. And there are some people who are really, really good at doing this. And they're kind of, it's kind of a hobby for them to come up with some really interesting regular expressions. I do have a cheat sheet, which I'm showing you now here, which you can download from my GitHub examples repository, and this kind of gives you a basic understanding of how regular expressions work. Okay, so there you have it. There is my introduction to regular expressions. Now, it is only an introduction because, of course, there is more that you can go into. But if you understand those basic concepts, you will be able to start using regular expressions for simple tasks. Okay, my name is Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, please do give it a thumbs up. Please don't forget to subscribe. You can also hit that bell notification icon. And, well, that's it. I'll see you in the next one. Can be quite complicated. They can become complicated.